Welcome to the video for 7.1 Endothermic and Exothermic reactions. If you need to look at your textbook, then it's pages 112 to 114. The lesson objectives for today are to know that reactions can be endothermic or exothermic. So the first thing you need to be reminded of is a concept that you'll come across at GCSE, which is the conservation of energy. So you should know, both from chemistry and physics, that energy can't be created or destroyed. It can only be transferred from one form to another. Therefore, if energy is lost from a chemical system, then it has to be transferred to the surroundings, which causes a temperature increase. If energy is gained in a chemical system, then it has to be transferred from its surroundings, so there's a temperature decrease. Make sure you get these concepts clear in your mind, because students often get confused between the temperature change and where the energy is actually coming from. So if the temperature increases, then that's because the chemical system is losing energy. If the temperature goes down of a chemical reaction, then that's because it's transferring energy from its surroundings. So in chemical reactions, there is normally an energy change in reactions. This is because chemical bonds contain potential energy. So it's like a elastic band that's been pulled tight and has potential energy. So chemical bonds are potential energy. So they're a store of energy. When you have a reaction, then what's going to happen is you're going to get existing bonds are going to break and you're going to form new chemical bonds. And because this happens, the potential energy of the chemical system is going to change, because the bonds that you make will have a different amount of energy than the bonds that you've broken. This means that a chemical reaction is going to change the amount of chemical energy of the atoms. So it's going to change the potential energy. So here's two key terms that you would have come across at GCSE. So the first one is exothermic. So the way to remember this is if you think of X, you then think of exit. So when you go out of an exit, you are leaving. So in this case, therm means heat, and the heat is leaving. So the heat is exiting or leaving the chemical system. So an exothermic reaction is one where heat is given out. So as the reactants turn into products, the temperature rises because the chemical system is losing energy, and that energy is going out to the surroundings. Then endothermic, so again you've got that therm part, which means heat, and N, you've got to think of entrance. So endothermic, the heat is coming in. So the heat's coming in, the entrance is coming into the chemical system. So an endothermic reaction then is a reaction where heat's taken in. So as the reactants change to products, the temperature drops. And this is because it's taking in heat energy from the surroundings in order to gain potential energy, that chemical energy. So here we can see a graphical representation of that energy change. So an enthalpy change. So enthalpy just means energy, and the change is the change that happens when you have the chemical reaction happening. So that triangle symbol there next to the H means a change. So the change in enthalpy is the enthalpy of the products take away the enthalpy of the reactants. And you can draw these as graphs. So on the left hand side we've got an exothermic reaction. And exo means exit, so remember the heat is leaving. So if the heat is leaving the chemical system, then that means the reactants have got to have more energy than the products have got. So on that graph you can see the y-axis is the enthalpy, and you can see the reactants are at a higher level than the products. So the reactants have got more energy than the products. So as the reactants go to the products which have got less energy, that heat then has to go out to the surroundings. And you can't see it very clearly on there, but the enthalpy change when you've got an exothermic reaction, we give a negative sign to indicate that it is losing heat, because the heat is being given out to the surroundings. If you look on the right hand side graph, that's for an endothermic reaction, and entrance, remember the heat is coming into the reaction. So if the heat's coming into the reaction from the surroundings, that means your products are going to have more chemical energy than the reactants have, which you can clearly see on that graph, because the reactants start off quite low, then once they're turned into the products have got more energy. And because that's a gain in energy, we give delta H a positive sign to show that the products have now got more enthalpy than the reactants had. You also need to know or be aware of the applications of energy changes and reactions, and again we talked about this at GCSE, so you should be familiar with it. Energy changes can be useful in everyday situations. So for example, hand warmers, you can get hand warmers where you have two chemicals which are then allowed to mix, and when they mix, that's an exothermic reaction. It gives out heat, so it can then be used to warm your hands. For self-cooling beer cans or drinks cans, if you have an endothermic reaction of two chemicals, you allow them to mix. It takes in heat from the surroundings, so it takes in heat from your beer, which then cools it. You've also got ice packs or heat packs for sports injuries and self-heating drinks and food cans. So you need to be aware of these applications. So lastly, we'll just go over the lesson objectives again, which were to know that reactions can be endothermic or exothermic. So as usual, go back over the video if you don't understand what's been said, and look at your textbook or online notes until you make sure that you understand everything that's in this video.